Good morning, everyone. My name is Felienne Hermans. I'm assistant professor at Delft University of Technology, also in the Netherlands, relatively close from here. And I'm going to talk today about how kids program. But before we do that, I want to have a little poll with all of you. Who thinks kids should learn to program? Let the record show that everyone agrees that kids should learn to program. So why? Anyone has a reason why kids should learn to program? It is fun. Yes. Teach them logical reasoning.
It's a great tool to create with.
It's a very good tool to create with. And we didn't set this up, I promise, but this is actually the thing I wanted to talk about a little bit more, because I was already an advocate for programming for children for a very long time, because the first reason, I thought it was fun, so, kids should learn it because it will give them great fun. However, I also like long-distance running, and I don't necessarily think that all kids should run marathons. So apparently there's something to programming that makes it different. It's not just about fun. And I really only understood why I thought programming was so important when I started knitting. Last summer, I started knitting, and I did some knitting as a teenager, and then I sort of forgot about it when I went to university, and I picked it up about a year ago. And something amazing happened in my brain when I started to knit, because I saw the world in a different way. All of a sudden, I was looking at sweaters, like that sweater. Oh, what type of wool is that? What type of pattern is that? Could I make that? I was very interested all of a sudden in all of the things knitted. And I think this is the reason why I want kids to learn some programming. And I'm not a great knitter. I really only have the basic skills. But already having the basic skills of programming allows you to look at things that are programmed and to think, hey, I could make this, or what skills do I need to learn to be able to make this? And I think this is why it's so important to go back to the society angle, for kids to understand some programming. Then they see Facebook and they realize this is a thing a person made. Well, many people over a very long time, but it's still something that someone created, like a sweater or some other crafts work. And that is the view I want children to have, to look at the world and think, hey, all these things software, I could make them just as I can make things out of wood or wool or whatever. So that's my motivation of spending lots of energy to teach kids programming, because I want them to not just consume technology, but also be able to be technology producers, and also to be able to participate in discussions. Last session was about politics. Politics is software. The Facebook bubble and WikiLeaks, and there's no more distinction between politics and software. And if we want the next generation to be able to participate in these type of discussions, then they need to have a basic understanding of software. Otherwise, it's over your head. So this is why this session matters, and you should not fall asleep and listen to all the rest of the cool things I'll go to tell you in the next half hour. So, how do kids program in the wild? Maybe you're wondering with this question, do kids program in the wild? Well, the good news is lots and lots and lots of kids are already programming. Maybe you know the platform code.org, which is a website where kids can take free programming lessons, and they already served 285 million children. That's a lot of children. Maybe you're also familiar with Scratch. Who has programmed in Scratch? To check it out if it's good for your children, right? Not for your own enjoyment at all. So many people are with you. About 18,000 projects are shared in the public repository. So not only are kids creating Scratch programs, they're also sharing them with each other for the world to see. So the good news is kids are already programming. However, then the question rises, what are they learning? Coming back to the answer of the person in the back, are they learning something? Are they learning, for example, logical reasoning? Or is it just a toy? Is it just something they play with? Oh, it makes a sound, it makes a movement. So we wanted to understand, are these programming tools toys? Or are the kids actually writing good, proper source code the way we would like to see if they ever become professional programmers? And of course, we know many things about programming. This is a picture from the good old days of programming, when all the programmers were still ladies. I really hope we can come back to that. in a future. So we learned a lot from those ages. We used to have huge machines and not a lot of structure. And then after a while, people figured out, well, source code is really nice if it's more structured and if there's more organization around it. And then OOP was designed. And a bit later, we got Martin Fowler that defined code smells and refactoring, patterns of source code that we think are good and well-structured, and ways to improve source code that isn't very well-structured, called refactorings. So we know these things. We don't have to pretend that kids are just coming into an entirely new space, because we know how to organize programming. So one of the first research questions that we focused on is code smells. Do they matter for children? If we give kids a good program or a bad program in terms of code smells, do they even understand the difference? So we used the Scratch programming language. And for those people not familiar with Scratch, this is how it looks like. So you see it's very colorful and inviting. You can see the interface right there. So the blocks are here. And on the other side, you have the instantiation of the source code. So it's somewhat of a live programming system where you can immediately see the effect of the source code. And what you don't see in this picture, because it's in English, is that the keywords can be localized to many different languages, so Dutch or Chinese or Spanish. So it's easier for kids to understand what's going on because they can read the blocks in their own language, even if they don't speak English, which makes it really accessible. And another reason that Scratch is really accessible, this is actually something I would like to have in all programming languages, is here in the middle you have all the blocks. So you don't have to memorize syntax. You can just read the blocks and you think, oh, this is what I need, and then drag the block over to the gray area, which is sort of super autocomplete because everything is there, not just the thing you typed. And that also makes it very inviting to kids. Even if you don't know anything, you can just drag a block. Compare that to when, guessing ages, when most of us started with maybe BASIC, you open the editor. I don't know. So you needed a book or a parent or a teacher. Whereas in this interface, you really don't need anything because everything is right there and you drag it. And there's even this little help menu that explains you how to start. So it's really very nice because it's so visual. So there's this thing called sprites. This is the item, this of course exists in many games, the items in the game, in this case, a cat and an apple. And each of the sprites can have its own script. And there can be multiple scripts, as you can see here, and they can even run in parallel. So you can have multiple events that trigger scripts in Scratch. Each sprite can have its own scripts. So here we're now looking at the code for the apple, so each of them can have their own source code. In a sense, they're like units. Like you could say this is a class because all the logic goes together. So we wanted to know again, do code smells matter to children? So what we did is we programmed a simple game, a breakout-like game, and we made 3 versions of this game. One version was a good version, this version, that we thought was properly, well-structured and easy to understand in theory for novice programmers. We also made 2 versions suffering from code smells. One with a long method code smell, in this case a long script, and one version with duplication, also called code clones, so repetition in the source code. And this is the nice version. This is the version with duplication. So here you see that this item is repeated. Here it is in the ball script, but this similar code is also in the script for the bat. So similar events occur in different places in the program, and we had a third sprite, the line. This is to detect if you are game over, and there again we had similar blocks of source code determining when the game is over. Punten, that's Dutch for points. And in the nice version, everything was together in one place. So if you wanted to make a change, you only had to make a change in one position. And this is the long method smell. Don't think I need to spend lots of words on why this is smelly, but as we will see later, this is not an uncommon pattern. What we did is we had, the short answer is yes, code smells matter to children. So we did an experiment, and the short answer is yes, code smells are bad for kids. Kids performed significantly better on the non-smelly version. However, there were differences between the impact of the code smells. We asked, for example, when have you won the game? And in the version, the non-smelly version, it was relatively hard to obtain this information because it only occurred in one place. And we added the duplication to make it harder, but in the duplicated version, the information, when have you won the game, if points is 5, was repeated. So wherever the kids were looking at this point, the information was always right there. So we find that duplication can even make it a bit easier to find the information, because the information is repeated as well. So understanding was more affected by the long method smell than by the duplication smell, because in this long method version, it's really hard to find the information, whereas in the duplicated version, this was relatively easy. Of course, when you start to think about editing, maintaining source code, this is when duplication can really be harmful. So an obvious question we ask the kids is, make the game go to 10 points, from 5 points to 10 points. And of course, there were kids that were very thorough and found all the 5s and replaced all the 5s by 10s. However, there were, of course, also kids in the this is the non-smelly version, you only have to change it once, but in the duplicated version, you have to change it there, and there, and there. And there were eager kids, of course, that looked at the first version, the first 5 they saw, this has to turn into a 10. And then they start the game, and you get inconsistent behavior, which is, of course, a pattern that probably many of you have also seen, like, oh, I'm sure this is the place where it has to be changed, and then there are other places where it also has to change. So duplication really hampers maintainability, but it doesn't necessarily hamper understandability. So that's interesting, I think. The code smells are bad, but they're not all bad in the same way. But the summary still is, code smells are bad, also for kids, which is more or less what you would expect, but it's still interesting to explore it. A question that you could ask then is, does this really happen? Is this a pure academic hobby of Felienne, exploring code smells for children while in reality these programs do not exist? Or is this realistic? So let me again extend my thanks to MIT, because not only have they built Scratch and open sourced it, they also have this public repository that I talked about before with about 17 million projects. I think by now it's already 22 million or something like that. It really goes quick. And all these projects that are shared are Creative Commons. So you can analyze them, you can look at them, you can print them out or have them tattooed on your back, or you could do some static source code analysis on them, because you can do with them whatever you want. And if you look at these programs, they are indeed made by kids. There are some people, like I'm there, and I saw some people in the audience, but most of the people that are in the data set are real children. So we can say with a certain amount of certainty that the programs we're analyzing are made by kids, because we can't trace one individual project to a kid. That's for privacy reasons, of course. And people are scratching everywhere. Look at that graph. Everywhere people are scratching, including also the Netherlands. But it's really an international thing, even though it was made by MIT. Now, you all, of course, are all curious. What do kids do in Scratch? How do these Scratch programs look like? So what we've done is we've looked at some programs, but not manually, but automatically. So we downloaded all programs for one day, for 24 hours. We just scraped everything that was coming in. And this resulted in 250,000 JSON files, because under the hood, of course, Scratch isn't stored in PNG files, even though it's a visual language. There's a JSON format behind it that's also very well documented, so we could easily analyze that. We flattened that into CSV files, so you have a list of all the blocks that are used, which is really easy. And if you're really curious now how often your favorite Scratch block is used, this dataset is on GitHub. So if you want to explore it, you don't have to go through all the trouble of downloading everything and parsing all the JSON. You can just download this CSV file that is just a list of all the programming blocks, and then you can really easily explore it. What we found in this dataset: many programs are really small. This is what you expect if it's a toy language for children, for young children to play with. This is the median program. So this is in the middle of size. Half of the programs are smaller than this. And this only has 2 sprites, 5 scripts, and 29 programming blocks. So relatively small. Most programs are simple. So if you look at cyclomatic complexity, 78% only has a cyclomatic complexity of 1. So there's no branching in the programs. Although this is a little bit tricky as well, because cyclomatic complexity is really made to measure more OOP programs. And as you can see, Scratch is quite event-driven. So there's choice. However, the choice is represented as events. But still, it's interesting. Conditions are relatively commonly used in 78% of the projects. Loops are commonly used as well, but you see that more complicated loops are used way less. So 77% of the projects use loops. However, this is like a while true is used very commonly, but more complicated loops, even a for loop that runs a number of times, is used less, and something that triggers on a condition is used even less. I think this is our most surprising finding. Here you see all the blocks that represent user interaction. So a button is clicked, someone makes a sound, user input is required. And what I was thinking is all these programs will be interactive programs. They'll all be games and things like that. But only 56% of the projects have user interaction. So almost half of the projects have no user interaction, which was surprising to me. And here again is this mindset of, oh, I like the things I like, hence kids like them as well. Not all of the Scratch programs are games. Many of them are, but there are also lots of Scratch programs that are animations. So they're just using Scratch to tell a story. And there's no interaction, you only have to start the program and nothing else happens. And you can also use Scratch a little bit like Logo, that some people might be familiar with, to make drawings. And you can also make Scratch to create music, so you can play music sounds. So many of the projects had no interaction. You could even say, is it really a program? If something is a story or a drawing, then maybe it's more an artwork than programming. So this was a finding that we weren't really looking for because we were exploring the code smells, but it was still really interesting because it changed my perspective of what kids do in Scratch, and with that also what kids like to do in Scratch. In Scratch, you can also create your own events. So you just saw the events like when a button is clicked or when the green flag is clicked, but you can also create your own events, and then you can broadcast them and then you can react to them. But this is not commonly used. Only 1 in 3 projects use broadcasting. This is, of course, because it's slightly more complicated. Variables aren't used a lot either. Only 1 in 3 projects has a variable, and we only saw more than 4 variables in 7% of the project. So the higher level concepts are harder. You can create your own blocks as well, which is like creating your own methods. Not commonly used, only 8% of the projects use their own blocks. And this is interesting, 62% of the procedure is only invoked once. So kids need to learn about reuse a little bit more, because then they create a block, but they only use it once instead of reusing it. So this could be very interesting to explore a little bit further, because what are kids thinking? Why are they exploring a feature? Maybe they don't really understand what it could do for them. So this could be something where you could interactively help children to understand the feature a bit better, because I don't think this shows that they really see the value or power. In conclusion, many projects are small and simple, but we saw some amazing projects as well. This is someone that has recreated Minecraft in Scratch. Because why not? This is a project with 300 variables, 300 procedures, and over 100 events. Like, wow, you are doubting a little bit whether this was actually a child or maybe an adult with no job and no hobbies other than making big Scratch programs. But this isn't the only one. There are functioning recreations also of Clash of the Clans and many other games entirely rebuilt in Scratch. So there are really huge projects that people make. And of course you are wondering, because I decoyed a little bit with all the programming features, but you are wondering about the code smells. This is what we started this whole endeavor for, why we downloaded all the files, because we wanted to understand what about code smells. This is duplication, a repeated code smell, and here we even look at structural clones. So as you can see here in the diagram, the parameters of the blocks are not the same. So we look at the structure, because in theory there is an opportunity for reuse, because you could reuse the entire blocks and then substitute the parameters for parameters of the block. So if we look at structural clones, 26% of the projects have structural clones, and 10% of the projects even have clones within one sprite. So the duplication is located next to each other, so you could really think there's a possibility here for some abstraction. If you look at large scripts, which we consider to be over 18 blocks, that's a long script, and we use the threshold algorithm that's also used in traditional source code analysis to set the threshold, then about 30% of the projects have large method smell. That's quite a substantial number of projects that have lots and lots of blocks glued together. Another code smell that we explored in the data analysis that we didn't explore in the experiment is dead code. There are various ways that source code can be dead in Scratch. The ways are visualized here. So for example, you can have a script that doesn't have an event to start with, so it will never be executed. You can have an event block here that has no code associated to it, so theoretically it's executed. However, then nothing happens, so it's not really active. The option 2 is dead code where a method is defined, a my block, but it's not invoked anywhere. And the fourth option is when you have created your own message, your own event, and you're waiting for that event to happen. However, you're never broadcasting it. So that's more like lonely code than dead code. It's just waiting for something that will never happen because there's no trigger generated anywhere. Dead code is also relatively common. The option 1 and 3 we saw in a quarter of the projects, and 2 and 4 don't occur that often, but that's also, of course, because those programming concepts, events, and procedures aren't used very commonly. And in total, 28% of the projects have dead code. We know from studies into professional developers that dead code can hamper understandability as well, just like long method or duplication, because you're not really sure whether it's going to be executed, so you'll spend time on reading dead code that doesn't really relate to the functionality of the program. So in summary, most programs are simple, but code smells are common. And we knew from our first experiment that code smells can be harmful as well. So now what do? Some people, there are people in the community that say, okay, so Scratch isn't a good language. If it allows children to make bad programs, then we need a better language that doesn't allow children to make these code smells, either by making the language differently or maybe by adding a resharper-like thing for children saying, no, this is not good. That's a vision you can have. However, the question is, of course, how long are you going to keep that up? Because at one point, people will move to more free languages, and then they have the trouble anyway. So our approach is more, let's educate children about code smells. If they're learning to program, we can, in the same time, also learn them about code smells like it's a very normal thing. And here, of course, my selfish motive is revealed, because these kids doing Scratch now, in 10 years, they'll be in my university classroom. So then I say, hello, children, don't make long methods. And they're, yes, but teacher, we've been doing this for 10 years, so we're not going to stop now. So the earlier I get them, this is an investment in my own future happiness. The earlier I get them in university, I will say, no long methods. And they say, yes, we know. Actually, there was one kid, so on Saturdays I teach in a community center. I teach programming to children, and there's one kid that has been in my class for 2 years. So we were looking at another kid's program. He opens the source code of that program. He looks at it, and he says, this is so messy. I can't work like this. And he starts rearranging everything. I'm like, yes, it's working. That is so cool. So I thought we could scale this up. I don't only want to teach the children in my Saturday club, I can do an online course. So we did an online Scratch course, and the first run we did, over 3,000 children participated in this course. Sadly, it's in Dutch. So if you have Dutch children, it's still running, it's still there, but yeah, it's only in Dutch for now. And the kids that took our course, 75% of the children were between 7 and 11, so real kids, because we also saw in our data set parents and even grandparents participating to check it out for their kids or maybe for their own personal fun. We tricked these kids slightly. So we said this is a programming course. It's a regular programming course. We will teach you about programming concepts, which wasn't entirely lying. It was true. However, we also taught them about code smells from the beginning. So every lesson we addressed a programming concepts, but also a code smell. And we presented it as sort of a matter-of-fact thing. Programmers don't like mess. Programmers like a clean working environment. So if you're done with programming, you just have to remove all the blocks you don't need. And here's a very long method. Don't you agree? It's very hard to read. Let's simplify it a little bit. So we try to really train it as a habit, like you train cleaning your toys, or like you train eating vegetables or brushing your teeth. You know, it's not super enjoyable, but it's just a fact of life. And this course didn't only include videos where I explained these things, but it also included tests. So we had tests about programming, but also tests about code smells. So here's a question about programming. It's a typical execution question. It says, if you press the green flag, what will be the value of X at the end of the program? Sort of traditional tracing activity. But we also had questions about code smells. So here I ask, there's one block too much. Which block is it? Which block can you remove and why? So we could measure both the scores of children on programming understanding, but also on code smell understanding. And with that, we could answer the question, are code smells harder to learn than programming concepts? And the answer is no. In fact, code smells are a bit easier to learn than programming concepts. Here you see the 5 concepts, smells that we talked about, and here are the programming concepts. And what you see is the score that all the children scored on all the questions together. And you see that they score higher on the code smells questions than they do on the programming questions, which is good news, because from that we can conclude that we can teach children about code smells, and they get it. What we also found, and we weren't really looking for this, but we explored ages, and we found that programming concepts, a lot of them, get a lot easier after the age of 12. And it's interesting to see that here it's sort of a flat line. It doesn't really matter if you're 5, 6, 7, 8, 9, 10, and then whoop, so all of a sudden you make a leap. So I was like, oh, this is so interesting. I made this very interesting finding that programming gets easier after 12. And that's like, this is this typical one-disciplinary mindset, because if you read any psychology book about how children learn and what they can learn, then it says, this is research from the 50s, it says, yes, kids get better in logical reasoning after the age of 12. I accidentally replicated some psychology research from the 50s with my programming study. Isn't that cool? So it was nice because it fits a theory, but we didn't even know that theory. It just came from the data. So that's interesting, and this is also, I think, a lesson that we can take from this research, is that there are certain things in programming that kids just aren't ready for. So if you're pushing your 6 or 7-year-olds on variables or procedures, it's just too hard for them. And this age appropriateness, we have a pretty good understanding of age appropriateness in math lessons and in language lessons. You're not going to say to your 6-year-old, let's do some differential equations before breakfast. You know that that doesn't make sense. But we do see similar behavior in parents and teachers, that they're trying to do very complicated programming concepts like abstraction, whereas we know from psychology that abstraction really is developed if you're older than 12. So it doesn't really make sense. And it might even be harmful. Maybe kids think, programming is stupid because they don't get it because they're not ready. So be aware that some programming concepts are more for high school age students than for middle schoolers. Oh yeah, and for operators, so things related to logic and procedures, this difference was statistically significant. So the things related to abstraction and logical reasoning is exactly what you would expect to increase after 12. So that was more or less everything I wanted to share with you. I know I speak very quickly, and some people came in late, so in order for you to be optimally prepared for question asking, allow me to summarize my entire talk in 1 minute. So if you missed anything, this is like your second shot to get it. Some people are jet lagged, or it's warm, it's late. But of course, if you did get everything, then this is the perfect preparation for asking me some tough questions. So I looked at the programming language Scratch, made by MIT, which is commonly used by many kids, and I wanted to know if code smells matter in the context of a programming language for novice programmers, and we found that yes, code smells hamper understanding even of novice programmers. We then wanted to know, are code smells common? We analyzed 250,000 Scratch programs from the public repository, and we found that many programs are small. However, code smells are common in lots of the projects. And then we set out to do an online study in which we tried to teach kids. And the happy news is we can teach kids about source code smells from the beginning together with programming concepts. That was me. I'm Felienne on Twitter, so if you want to tweet about this session. And also there's an app, I think, for giving feedback that requires my Twitter handle. Again, my data set is on GitHub, so if you want to check it out, the scraping program and the data set as well, so you can do some analysis on your own favorite topics. And I blog about my research as well. This is a link to a Dutch website about my research, but if you just go to my website in general, then you can also download all the papers there, download many of the data sets to do your own analysis. Or you can ask a question now.